Algebra 1 students, welcome to your 6.5 notes. Today we're going to look at graphing linear inequalities. Now the process to graph linear inequalities is very similar to what we do when we graph linear equations. There are only a couple of changes. One, we have to consider, is our line solid or is it dashed? We'll talk about when that happens. And then also, do we shade above or below, and how do we figure that out? So of course we'll consider that as well. So let's start just by talking about the two additional things we have to consider, being the shading and whether the line is dashed or solid. A dashed line means that the solution doesn't actually exist on that line. It's up to that point but not including. So anything that's not equal to is going to be dashed. Like we have here the less than symbol and the greater than symbol. However, whenever it's less than equal to or greater than equal to, or for that matter if it's equal to, then the line is part of the solution, so those would be solid lines. All right, the shading is going to is basically we shade where the solution exists, where the inequality is true. Anything that's a less than type equation, when we're in slope intercept form, we would shade below. And the same thing, if it was less than equal to, we would shade below. Whereas if it's greater than or if it's greater than or greater than equal to, we shade above. You can see an example here, y is less than x, and you can see at the beginning what we have is a line that's dashed. It's the line y equals x. It's dashed because it's not included as part of the solution, but it's everything beneath that line. Another consideration for us that I probably need to make more of a point of is these statements we have about whether we shade above or below are all in reference to our equations being in the form of y equals mx plus b. And if we aren't in that form, y equals mx plus b, then we have to use other methods. But as long as we're in that form, slope-intercept form, then that works. All right, so let's take a look at this one. It says to graph the inequality. The first thing I notice here is that we have a line that's in slope-intercept form, y equals 1/2 x minus 3. So I notice right away that my slope is 1/2, and the y-intercept is -3. So I'm going to start by marking those points. There's -3. My slope is 1/2, so I'll go up 1 and right 2. And I'm going to mark a few points here. I might go the other direction as well. Now I need a dashed line. So what I'm going to do, I have the nice feature being able to do that just like this. You may have to be a little more creative with the way you do the line, but our line should be dashed. Now why is it dashed? Pretty simple actually. It's because of this symbol right here. It's less than. It's not less than or equal to. All right, the other thing we have to consider is where do we shade? Well, this one is in slope-intercept form, and it's also a less than equation, so our shading is below. So we'll just shade below that line. I'm going to do a quick shading job here, and we're done with that question. Okay, our next equation is in a little bit different form. It's in standard form. Now personally, I prefer to graph this by using intercepts, so I'm going to go ahead and do that. If you prefer changing to slope-intercept and graphing that way, you're more than welcome to do so. So here's what I'm going to do. I'm going to say if x is 0, then I would know y would have to be 2. And in a similar manner, if y were 0, I know x would have to be -5. So I'm going to plot those 2 points, -5, 0, 0, 2, and I'll connect with the line. Now notice this time I'm using a solid line, and the reason for that is it's greater than or equal to, so we definitely want to make sure that we have a solid line in this case. Sorry, I'm having some issues getting that line just right. Okay, now we can't just trust the greater than symbol when we're in standard form. We're going to do a method where we test a point. Now, to me, the easiest point to test is the origin. I think most of you would agree with me. So I'm going to test the point 0, 0. I marked it here, but I'm going to test the origin. So we're testing 0, 0. What I'm looking to see is this a true statement? So negative 2 plus 0 times, plus, excuse me, 5 times 0 greater than or equal to 10. So we've got 0 plus 0 is greater than 10. Is that true? Of course not. 0 is not greater than 10. It's less than 10. What that tells me is this point right here, 0, 0, is not part of the solution. So instead of shading below the line, I'm going to shade above. Now I would imagine some of you are looking at that and saying, well, it said greater than. We knew we had to shade above already. That's not really true though, because there are situations where a greater than symbol from standard form could lead to shading below it. Depends on the value of y. So with standard form, I'd strongly encourage you to test a point. It's the most reliable way. Okay, here's our next one. Now this one actually starts with a little bit easier equation to graph. I'm just going to go ahead and graph it. X is less than or equal to negative 7. So all I have to do is go over here. There's negative 7. It's a vertical line, if you remember that Hoy-Vux thing that we've talked about, oh, so many times. But here's the situation. We can't shade above or below a line that's vertical. So we have to think about it this way. It says x is less than or equal to negative 7. Where is x smaller than negative 7? Well, how about when it's negative 8 or negative 9 or negative 500? So our shading is everything to the left of that line. So the story here is anytime you have a vertical line, the shading is no longer above or below. It has to be left or right. It's just the nature of those problems. They're kind of the exception to the situation. All right. Determine if the ordered pairs are a solution to the linear inequality. We've used this process when we tested the origin 2 problems ago. And basically all we're doing is plugging in values. So I'm going to do that. 7 times negative 1 plus 2 times 1 is greater than negative 5. Now I'm going to put a little question mark here because that's what I'm trying to test. Let's see if this works. Negative 7 plus 2 greater than negative 5. And then negative 7 plus 2 is exactly negative 5. Now the question is negative 5 greater than negative 5? And the answer there, of course, is no. Now, if this problem had said greater than or equal to, that would be a different story, but this is most definitely a greater than situation. And I have no idea what this box is here. Sorry. We'll live with it. All right. Next one. Again, I'm going to plug in points. 2 minus the y value here is negative 1, less than or equal to 3. So that we could rewrite as 2 plus 1 is less than or equal to 3. And 3 is less than or equal to 3. That's absolutely true. 3 is not less than 3, but it's definitely equal to 3. So we would just say yes. All right. Write the inequality that represents each graph. Now these problems are basically working backwards from what we've been doing. Now I think I was pretty nice on the setup on these to give you pretty reasonable line equations to find. So I'm going to look at this one. Let's first find the equation of the line. And I notice a couple of things. I notice that my y-intercept is right here at 2. And I notice the slope is down 2 and right 1. So my slope then is negative 2. The equation for that line then would be y equals negative 2x plus 2. However, this is not an equation. This is an inequality. So that equal to sign needs to change. I've got two things to consider. One is the line solid or dashed. This is solid. That tells me it is going to be equal to. And then the second thing is, am I shaded above or below? And in this case, the shading is below the line. All of this is below the line here. So what I would say then is y is less than or equal to, I somehow missed a negative sign up there. Sorry about that, guys. Negative 2x plus 2. All right, last one. Same kind of instructions. Write the inequality. This time the y-intercept is negative 3. And to find the slope, I go up 1 and right 1, 2, 3, 4. So my slope is a positive 1/4. Now, if we just wrote the linear equation, it would be y equals 1/4 x minus 3. We have to answer those same two questions, though. Are we shaded above or below? And is the line solid or dashed? Now, this line is dashed, so we know there's no equal to in the equation. And all we're going to have here is y is, and it's shaded above, so it's got to be greater than. Slope is 1/4. Y-intercept is 3. There's your inequality. All right, folks, I hope this lesson helps you, and when you come to class on Tuesday, we will work on this. We'll also finish up a little bit from 6-4. Enjoy your weekend. Thanks, guys.